So we are back on where we were last time. Okay, now let's start deleting a few stuff. We're not going to need the AI director for quite a while. Okay, so we're going to delete that and we're just going to work with one of these. There's no need to use all of them because we have a lot more stuff to do. But we're going to reuse a lot of the same logic basically, which we seen on the previous part, to see what else we can do and what else we can add to our AI. So let's open this up, and right away, of course, we need to change this back to a regular update. Okay, and we also need to bring back over here if we are in view. So let's do this super fast. Okay, let's call this in view, and we're going to say if we have if the target is null, just return, so we do not really care. And we're going to say otherwise find the distance. Let me between our own position and of course our target position. Okay, and if that distance is lower than, let's say, 10, which will be a radius, or actually let's just write it into a single line. Okay, is in view will be if the distance is lower than 10. Now that I think of it, if target is null, we're also going to say is in view will be false, and is in view will run the behaviors we have over here. And what we also want to do is throw the new function in here. Okay, so we are pretty much back where we were. Now of course there is a little bit of something we haven't seen yet. Okay, now if the player goes inside the view of our enemy, okay, he looks at him basically, and you can see this, it works as we expect it, as we expect it to work. Of course, if you move too fast, then the enemy will lose sight of you. But the problem now we have is that if there is a cube or if there's a wall, okay, nothing happens. It's still the same behavior. So even if the wall was in front of you, okay, we still have the same behaviors. And of course, I'm pretty sure you know what we're going to do over here. We're going to make inside this, we're going to make a raycast, but instead of keeping it over here, let's make a new function and let's call this look for obstacle, or we can actually put all of them, it's the same function. So let's encapsulate all this, and we're going to take all of this, copy paste it, place it in here, because we want to reuse this. I'm looking into categorizing functions per different state, so we're going to start a little bit to see making a finite state machine. Okay, we're going to see a little bit of the basics. So we have everything in here at this point, and let's just throw it over here, and let's see, we will do a regular raycast. Okay, and let's write the origins. The origin will be our own transform position, but let's add a little bit of of an offset from the ground, so it's not directly from our feet, and of course the target direction will be target, and we already have the direction. Okay, it's here, so there's no need to rewrite it. So we can do if physics recast origin, okay, direction, out hit. The distance should be 10, the same with the radius. So let's make this into public float. Let's call this the radius. Actually, let's not make this public float. Let's just keep it as a float at this point. We won't care about it. Okay, and if we hit something, then you actually have you can actually start rotating. Let's just drop it in here just for now, and we will come back to it later and see how we can categorize it. So let's make sure they are on the same Y level, and let's create a box, something that will be our wall. Okay, so we have a wall in front of our AI, and what we also forgot is that we haven't yet categorized this. So we want if hit, and I think we had, let's see, we had a tag, yeah, we had it. So transform compare tag with, let's just put player now, and we'll see later. Okay, hit play. Even though we are inside the radius, okay, we see that we do not have a clear view of our player or our target, so it doesn't rotate. And actually this, and yeah, it doesn't rotate also because we need a collider for this. Sphere collider, and since we move this, we should probably add a rigid body too. Okay, and now it should work. Well, it doesn't, and it doesn't. Let's see why. We have in view, maybe we forgot to assign the target. We haven't. So let's review this. We have origin. Well, actually, let's do a debug log and see what hit the transform.name gives us. Okay, this hits this cube, so that means there is an issue. So there is, we have a direction, but maybe our direction, yeah, our direction is wrong because we use this. So what we're going to change over here, we're going to say vector 3 rotation direction. Okay, and that rotation direction will be will start as the direction. Put this over here, let's replace it. Okay, because we were removing the Y, that meant that it should have been around the same level as the player. And if we do a debug log, debug draw array, let's put over here, debug draw array. Okay, origin and direction multiplied by the radius. Let's put back the direction to the rotation. Okay, and let's hit play now. So let's hit play. Okay, that was the problem. You can see that the debug draw array goes way above its head. Even if it rotates, for it to hit it, it had to be over here. So let's go back and let's add the rotation direction for him to rotate, and you will see that the debug draw array will now be in its and it's not because we actually have because on our origin we add a vector3 dot so if we delete this, or we're actually let's just delete it for now and we will see later. When we have a floor, we're going to worry about it later. Okay, you can see now that it hits towards our player. So let's see what we're going to do now. Now we want to separate this, okay, because this is a raycast, as you can see, and we're still using the physics to find if we're looking or if there is any collisions from our object. And if we have, well, we have our debug draw array over here. So that means, as you can see, that we still do a raycast on every frame, which there's no need for this. So let's start and create the basics of a finite state machine. Now this is probably not going to be the final one we're going to use. We're probably going to change this. Let's just put this AI state. Now we can add close, distance, and we can change this depending on how far or away the player is. And we might do it this way, or you can use it from a director. Probably for checking distances, probably the director will be the best case scenario for this case. And so let's just go with idle, and in radius, in view, and we can of course keep stacking stuff, but that won't really, for this example, it's not really going to be that much needed. Let's just call this AI state, and let's call it AI state again. Okay, then on start, even though it's going to assign the first one, which is the idle, which is what we want. Okay, just let's be safe, so in case you write it in a different way, this will work also. And let's see, so we have 3 states, and which ones we can reuse, and we can separate this into a few different frame cycles. So for example, on idle we can update him on every 30 seconds, every 30 frames. In radius we can drop this down to 15, and when you are in view we can drop this into every 5. Okay, we'll see. Let's just start and we'll see how it goes. So the first one will be, let's call this not cycles for sure, let's call this well, actually we can call it Bob for all we care. So let's call this every frame. Well, actually no, every frame we do not need it. Let's call this late frame, or delay update, or delayed frame. It's too long, so we'll just go with dframe. And the cycle for this, we can keep checking every 10 frames. And after that, we can get dframe actually is not really that much of a clever name, to be honest. So we have 3 ones, we have 3 behaviors, or we can create 3 delegates for our behaviors, and one will be updated every frame if we need to, and only if we need to, actually need to. However, that will be also based on the AI director. Okay, so when the AI director says that, you know, you should update on this frame, it will always run that behavior. So what basically make him rotate, stuff like that, should probably be there. The second one will be, you know, checks that wouldn't necessarily change from one frame to the other. So for example, as we've seen in the previous parts, when you are checking the distances, if your player doesn't move that fast, okay, and he probably doesn't, so there is not so much difference between each frame on the position, you know, the delta position of your player, then there is no need to check for it, to check on every update. So I'm just going to call this late behavior, and I'm just going to leave it at that, and let's give it 15 for now. And let's call this late big counter, and it's what it's going to actually count. For all the frames, we do not need, of course, a counter. We have our updates, and let's call this WL late behavior, and let's just drop this 35. Of course, you can tailor it to be whatever you want, okay, and depending on the needs of your game. So now what we can do, depending on the states, we actually don't need to run all our behaviors, and we won't actually need to run in view in all of the states. Okay, so we can keep separating this and breaking it apart and only using it where we want. And of course, this can scale up pretty normally, so you have even more advanced behaviors. This will check it, this will, you know, allow it to do so. So what we need, we already have the target. We're probably going to need the direction, of course, and we're probably, let's see what else we might need. We have target, direction, the distance, we can keep it as this. Now if you have more than one target, in this case you can create all this into a different class and then use a list or an array and check for every viable target. You can check this. Now if you have more than one target, you should think of it like, what is the easiest thing to do? If you have 50 opponents and you have 5 players, okay, performance wise, what will be more logical? Searching for each 50 opponents, searching for your 5 players, or searching from your 5 players if they are in range of any other one of the 50. Okay, and probably you do not want to run 50 on 50 opponents, search through a list of 5 entries. You simply want to run those 5 entries, okay, from your enemy. So this can be very modifiable, of course, and we can go into way more advanced stuff than what we are going to need. Okay, so for now we're going all to focus with one target, and we'll see later how this can change. Actually, we can make it into a class now that I think of it, but it might just be overcomplicating it. So for now, let's just keep it and we will see. So let's break these functions, and what we're going to do is distance check. Okay, so if not if, distance will be, let's copy paste actually. Okay, the next one will be is clear view, which is going to be arraycast. The origin, we're going to still keep it as a transform position. We're just going to actually place it a little bit above because we want to reuse the direction. Okay, we want to place it a little bit above our guys so they do not hit or clip on the wall. So we're going to get this arraycast hit, and let's actually just take all of this and be done with it. I'm going to delete the rotation for now from over here actually, and we're just going to leave it at that. Let's just keep everything as it is in this case. So we're going to put the check elsewhere. The distance, we can handle this differently, so let's remove this also. Let's see, we have our direction. We also need an angle check. Okay, angle check, and let's take all this. We also need the rotation direction, so let's take all of this with our checks for our problems. Okay, and now we have our rotation, which for the rotation we're going to do void, and because we can actually reuse this one also, or we can recreate it, but let's just reuse it since that will require less amount of memory, even though it's a few bits. And we do not have somewhere where we create the direction, so we also need that. Okay, so it's clear view. We have our angle check in view, and we have here rotation, rotate towards target, and let's just take all of this, copy paste this and put it over here. Okay, so what we're missing is this and these three checks. Let's call this find direction. Okay, and our direction will of course be target.position minus transform.position. And since we are here, we can also update entirely our direction from direction, and rotation direction will be 0. And now we can actually delete this. So we have broken apart all our almost all of our logic. What we can also now do is we can add is in view, is in angle, okay, and bool is clear. If it's clear or not, we're going to add this. If we hit it over here, is clear will be true. Otherwise, Well, actually, let's put it over here. It's clear. False. Okay. So it will, every time we run this, it will start as false, but if he hits the player, then it's going to return to true. Okay, and the angle check we can add is in angle. Okay, let's just go with lower than 45. And I think we have all the stuff we're going to need. So, okay. Okay, excuse me for that. Now, we were over here. So now we can either start breaking apart our behaviors and, you know, categorizing this a bit. So, we're going to create public function, and we're going to keep it public so that we can, you know, control it from somewhere else. And let's call this change state. Okay, this is going to, of course, get the target state we want. Okay, and for the switch, oops. And we want target state, and we have our 3 states. And obviously, not that there's going to be you know, an issue with this, but we will probably want to run this at start, you know, just to make sure that we are updating this. Okay, now what we want is to, well, we're going to create delegates. Okay, delegates are empty functions, or, you know, not functions, they are pointers, which means you can actually add functions into them. Okay, we have covered delegates a lot before, and we can use them as a variable. Yeah, so you can have, because they are like variables, you can pass them around easily. So that means you can pass around, you know, functions. So let's call this, okay, delegate void. Let's call this every frame. Okay, and actually I want to capitalize on this, and we'll call this every frame, and we have our delegate, our first one. Let's call the other one late frame, and let's call this late frame, and we want one more, late frame, oops, and let's call this late frame. Let's just go with LL frame. Okay, so we're going to, let's call this also late frame. Oops, yeah, late frame. Let's call this late frame counter, and now we're going to have late frame. Let's call this LF counter. Okay, every frame we do not need to have a counter. Okay, our counter is the actual update, which can later become our tick, and, you know, so on. So what we can do over here, the first thing we want to check is, of course, our every frame. But if every frame is not null, because delegates can be null, of course, then we can say run every frame. And now we will keep adding on our frame counter, every frame we're going to be adding 1, and if L frame counter is higher than the L frame or the max, we can call it max, then what we're going to check if late frame is not null, okay, then you can run your delegate behaviors, which we're going to add there, and we want of course to reset our counter. So same for the LLA frame counter, okay, and we can say if LLA frame counter is higher than LL frame, then we can say if late frame, that's the delegate, is the I forget the name, okay, it's not null, LLA frame, we run the behavior, and of course we want to reset the timer. So what this is, we're going to be updating, depending on the state we are over here, we're going to be updating the statuses. So we're going to also have a function that well, let's just call it monitor states for now, and we'll see what we're using. So on idle, basically what we're probably going to need is the distance check. So we can do this on every frame, we can do this on late frame, or even if the distance, we can have another distance check, so checks if it's way too far away, it can drop him on the late frame instead of the late frame. Well, actually let's just use it. We have our radius, let's call this max distance, let's just call this at 30. Okay, the numbers I'm using for all of this are entirely random, so you probably want to change this to depending on, and you know, tailor it to work for your own you know, case. And we're going to put this distance check, okay. So on let's create another yeah, we can use the idle, or let's call this late idle. We still want to start on the idle state, and if it's on the idle state, on the late idle, then it can simply, it's going to change this by itself. Okay, because if you are on the late idle, you're not going to jump idle and go into in radius or in view. Okay, it's not logical, it cannot happen because we are in a finite state machine. So since this is only the idle, we're only going to use the late frame. When you are using delegates, the first time you're going to assign it, okay, you need to assign it with an equals. If you add more behaviors, so for example on the late frame, we want to, what we're going to need and to update is the distance check. And actually you need to assign it like this. Okay, now if I wanted to see if the view is clear view, then if I assign this with, okay, with an equal sign, it's exactly like saying if we have a float, okay, test 5, and then you go and say test equals 10, it doesn't add, of course. For it to add the 10, on top of what you have and not replace it, then you need to assign the plus sign. Okay, so with this in mind, okay, in this case we're not going to need is clear view inside, especially over here. Okay, so we're going to delete it. Now if he's in radius, and well, we can have the late idle, but instead of using the late frame, we will drop it on the late frame, the distance sec. Okay, so it's going to replace it. And what we should also do when we are changing a state is we first should basically empty all our delegates. And we do this because if you do not empty them, then it's going to run simply the previous behaviors we have assigned. Of course, it's not something we want to use or we want to do. So every frame will be null, and late frame will also start as null. Okay, so idle and late idle, they're still doing the same behaviors, but they are doing it on their own time. In radius, we can start worrying about more stuff. If you want it to be, you know, a little bit more, how should I say this? Yeah, you know, you want to use late frame or a late frame. Probably late frame will be enough. Okay, we still need to do, of course, a distance sec. Otherwise, you know, he might go away and it will never update. And we also need to do a few more stuff. We can drop in is clear view. Okay, we of course need the angle check, and we also need to find the direction, now that I think of it. So because this is yeah, this and this should probably be in the same, no, yeah, we're going to add it by default. Yeah, so if he's in radius, we're going to say, let's drop the find directions, but we're going to move it on the top. So Ctrl X, distance sec, direction, we find our directions, then we check if it's then we need to check the angle view. Now of course you can just simply use you know, encapsulate it in radius. Okay, in something like this, and do it instant check is clear view, and do this for each one, or you can simply and then assign this into the late frame. But yeah, it comes down into the preferences. However, this will give you a little bit more control if you want to pass something onto these functions. Okay, because to assign a delegate in here, it needs to have the same signature. So if you're, so for example, you cannot assign this into a delegate because it doesn't have the same signature as this. But if we had a delegate, let's call this test AI state, something like this. Okay, then you can do this. Test will be change state, and you also need to oops, you can assign it over here, and then when you need to call it, okay, we'll be calling it like this. So it's going to run the behavior like this with the assignment you have over here. Okay, so to assign a delegate, keep in mind you need to assign the same signatures. So as I said, you can just use this, but in this case you can see that we do not have some special behavior. If you have multiple targets, you might want to assign one of these, so you can also assign the target over here, so you're not checking the distance with a target. Let's do it like this, now that I think of it. So you know, it's easier afterwards let's keep it like that. So it's easier afterwards to change. So what we can say is in radius behaviors, and instead of assigning a target, we can just do this. Okay, and we're going to delete, we're going to rename this player target just for now, because it makes more sense to just use, you know, transform target. Let's take all this, copy paste it, copy paste it, copy paste it, and copy paste it. Okay, so of course the first thing we want to do is if player target is null, then simply return. And we do this because we do not want to write, you know, if target is null into all of these functions. So what we're going to do now is distance check, and let's just drop the player target in. Oops, not the target. Okay, it's clear view. Let's drop all of them in here first, and we are going to categorize them as they need it. Let's drop the references so we do not be annoyed by all that. Okay, so the first thing, when you are in radius, what you're doing, we won't need this, so delete that. Let's see. We won't also need this over here, so let's move it, let's keep it all that, because we only rotate this from the direction. Let's see what else we do not need. We need it over here. And on angle check, we also don't need a target for this because we are still using the direction. And since we also have the rotation direction as, you know, as a base variable, we won't need this one also. Okay, let's delete this. So we first check if the player is in a radius or not. Then we're going to check if he's in angle or not. No. Then we're going to check the direction. Let's see where we find the direction. Okay, we use the target. Okay, this is correct. We check the radius, find the direction, and from the direction you create the angle. You can find the angle, and if you have the angle, you can check if he is in clear view or not. Okay, simple. And we can take all this, and instead of adding it over here like we do, let's comment this out for now, and we can say over here on late frame in radius behaviors. Okay, you can do the same for idle. So, or basically this can be just a simple hook, but let's just call this, just to have consistency, let's just call this idle behaviors, and we're only going to add the distance check and in this case the player target. Now I'm using the player target, but if you have a list of enemies, then that means you're going to want to decide on how you're going to be passing your current active player or the current player you are looking forward or you are looking for. Okay, so let's take this, delete this, put it over here, idle behaviors. It's going to be the same for this one, for late idle. So when he is in view, what we're going to need is, of course, rotate towards. So let's put this on every frame. You're going to rotate towards the target, and we can still do these behaviors. And actually, yeah, that's not what I wanted to write. I wanted to write this. Okay, so if he's in view, we still want to run the behaviors because we still need to check the distance, we still need the direction towards our player, we still need the angle, and we still need to know if there is an obstacle between us or not. Okay, so it's kind of going to change, but because we're going to have a new function called monitor states, it's going to we're going to have a little bit more control. Now this is, of course, is very fair and we're pretty early on, but at this point we are only laying out the foundation, so for something that we can actually modify a lot. Of course, we're still making it. Okay, and yeah, this might be a little bit more complicated at this point, but if you're going to have something that is very robust and it's going to have a lot of stuff, you're going to need creating the tools that are going to manage all of this first. Okay, it's far more important than actually creating the behaviors, because there's no point in having, you know, a system that nobody, not even you, can work with. Okay, obviously. So we have our monitor states and we have all this, and what we need to do now is we have our public functions or our public variables over here. We need to change states depending on all of these. So the first check I want to do, though, because it's kind of a clear not a solution, it's kind of a clear change of state, and you kind of want to, if you want to categorize it even more, you're going to have your states where the enemy doesn't have anyone in sight. Okay, he doesn't have a target, then he's doing whatever he was, you know, supposed to be doing. And the other way is that the enemy has actually a target, and he's going to do stuff that, of course, we assign, but they're going to be completely different from what he was doing if he wasn't having a target. Okay, so this is more still categorization, but let's take it for example. Let's say Metal Gear. Okay, it's a stealth game, and when the enemy wasn't on an alarm state, okay, they were going about their business, you know, going naked in showers and stuff like that, or weird stuff like that. But when they were seeing the player, or Snake, or Old Snake, or Big Boss, or, you know, all of them, and then of course they were going to attack you. They were going to, you know, come close to you until they identify that you are an enemy. But if you manage to escape them, okay, they didn't just go back into their idle behaviors. Okay, they will search around, they will do other stuff until some time passed or something else happened that they will either forget, or they will die, or they will whatever they want. Okay, so even if he's is in view, or the target enemy, or well, the player in this case is in view. Okay, if it goes out of view, we won't be updating back to the idle just just based on the distance, if you are in radius or not. We can still do it, of course, but in most cases we're still going to have more logic on that part. So the final thing we're going to see for this part will be, we're going to just simply use this case, and we're going to say if we are in view, okay, we're going to drop this at that, else we're going to check our behaviors. So we're going to check if distance is lower than, let's say, well, actually we can still use a switch now that I think of it, and we can reuse this, I guess. Let's see, let me think. So we're going to say, if, let's go with this, if distance is lower than the radius, then change state to, you're going from in radius, in radius. If distance is higher than the maximal distance, then change state to late idle. Okay, if distance is lower than maximal distance, and here's how, we should probably just break it apart, it's going to make more sense. AI state, let's delete all this. Oops, we want the small one. So on idle, what we're checking is if distance is lower than the radius, change state to radius, and if it's lower than the radius, then that means it's probably not going to be higher than the maximum distance. Oops. So this will be in radius, change state to late idle. Okay, so it will either be one of these. In most cases you're probably not going to have any other cases for when you are on the in idle state. When you are on late idle, then the only thing you need to worry about is if you are on lower than the maximum distance, then that means you are inside the idle state. Okay, if you are in radius, then you probably only need to see if you are in view. So if you are in radius, then you're going to say if in view, then we are changing the state to in view. Okay, and we also need to check if the distance is higher than your radius, then you're falling back to the idle, and so on and so on. And if you are in view, let's just leave it at that. If we are in view, we're going to see later, we're going to add on the next part, later we're going to adding a counter, we're going to introduce pathfinding, we're going to add a lot more stuff on this. So let's drop this and let's go and start testing it. We can't just drop it from the top. Okay, monitor states. Let's hit before we hit play, we should probably throw a debug log on what state we are actually in. So let's throw backlog AI state. Yeah, probably toString is a little bit redundant, but anyway, let's be let's start from over here. Okay, you are in idle, still in idle, and because we also do not have a player target. So what was happening is it was going to, basically it was never run these behaviors. Okay, and this we should also add an if player target here. Okay, if he's null. So let's drop the player. Oops. And let's hit play now. Where is the player? He's over here. He's on, let's see, let's comment this out. And because I forgot the maximal distance is 30. So that probably means we might not be that close. Let's see. Hit pause. Let's hit play. We are in idle. Okay, because of course. Oh, and yeah, I'm a genius that actually forgot to to change the AI state over here. Okay, forgot to assign the AI state. Oops. Okay, in idle, in radius, for some reason it thought we might have forgot something. It thought that it's in radius, but you can see that it's just in late idle. And after we get close, okay, you can see that it runs the in idle behavior right now, and if we go far away, it will run the late idles. And if we go over that wall, and you can see that it's jittery because it happens every 15 frames, every 10 frames, basically the number we have set it up. Okay, so it's not using the physics on each one. And what we also forgot to assign, I think, is that we forgot to make the guy rotate. So what we need to do is simply in view change state. Well, actually, what we forget, every frame. Well, this would probably target rotation direction. Now, because not the in-radius behavior, we need to know the direction. So we also need to check, we need to drop the find direction. So let's make one of these again. Void, nope, let's just keep it over here. Void in view behaviors, which what we're going to do is rotate towards target. We do not need to pass a target, okay, but we still want to know the direction, which to update the direction we do this from over here. Find direction, player target, and if player target is null, then do nothing. we return. And we're going to run this, and let's just drop it inside every frame in view behaviors. Okay, but you can see that I can still reuse. I can still use the in-radius behaviors. And yeah, let's try this now. I believe it's going to be in radius, and it actually never is clear. Yeah, we actually made one small mistake on our monitor stage. We do not want is in view. We're not actually using in view anywhere right now. Okay, so we need to know if it's clear, not if it's in view. If it's clear, then it's in view. Okay, and you can see that the hotfix make him rotate. Let's hit play again. He's in idle. For some reason, again, it said in radius. Now these are not the normal update. These are the debug logs are every frame. Okay, they are not on their normal update cycle. As you can see, we are in radius, so that means we are under the maximum distance, so that means we are in idle. And about over here, we are in radius, so that means, you know, he needs to keep thinking and keep doing it a lot more. And you can see that it does this on every frame. Okay, not on every frame, on the frame counter we have added. And if we go from the top, you can see that it does this. It rotates around and he shoots array every frame, every 10th frame or something like that. And even if we go back now, he's still on the in view behavior because we have set it up like that. If we do not want that, then what we can say is, let's just drop the distance. If the distance is greater than the idle, then let's go back into, you know, the radius. Let's try this now, and we're almost done. Okay, we have this. We have our idle. We have in radius. He's in view, and back to late idle since it's higher than the maximal distance. And now, instead of dropping the debug log over here, let's drop it inside the, okay, on every frame we do not need to have a debug log. We know where the debug log is. And let's just drop this, and let's say late frame plus AI state, or probably late frame for late frame. Take this. Well, actually, no, this wouldn't be. Or can it be? Yeah, let's just do it for now. I guess that will kind of prove my point, what I mean. Or let's just put this in some of the functions. Let's just put this on the distance check, since we have it on almost all our behaviors. Let's call this distance. Okay, you can see the distance. Let's remove the other one. We do not need this. Let's hit play. Okay, notice the distance, how far, or the rate at which it updates. Because we are on late idle, it updates every 30 frames. So that means if you are running with 60 FPS, then that means it updates, it checks for distance twice a second if you are running with 60 FPS. Okay, if we go closer, you can see that it sees that it runs from a different function, so it outputs it as a different debug log. Otherwise it would have been collapsed under the same one, so it will only be adding the one. And you can see that this is significantly faster. If we go even closer, we're going to start be seeing even faster, and we also be seeing the raycast radius. Okay, he doesn't know that we're there, and if we are over there, well, the debug, the distance check is pretty much the same as the in radius. Okay, because it makes a little bit more sense. Okay, but in most games, so for example Call of Duty, it doesn't even have a distance check. It's all scripted so that they know that the enemy is there and they attack and they run their behaviors. Okay, so depending on the game we're going to do and we're going to make, we might want to just check this or reorder this to be on what we actually want to have. Okay, and I think for the third person shooter, we're actually going to do this without a distance check. As far as single player is concerned, both AI of course is different. And I see that we forgot to fix the Y, so let's fix this also. And we have our direction, so this will be rotation direction instead of direction. Let's try it now. Yeah, it rotates, but he doesn't rotate up and down. So that's it for this part. Of course, it's a lot of stuff, and the more stuff we do, we're going to be making even more and more complex stuff. So you know what to do. Like, subscribe if you like to see more and you like to support me for what I do so I can keep making all of this, then by all means feel free to support me either on Patreon or by grabbing a project or two from Gumroad. And I'll see you next time.